We're now looking at trying to find the area under a curve, which really is our long-term goal of integration. So I'm going to start out by graphing this curve. You absolutely do not need to do that in the future. You don't need to draw the actual graph. You just need to understand how to use the equation in order to find the area that you're looking for. But hopefully by showing it graphically, I can show you what's kind of going on. So here we start at 2. 1, 2, 3, 4, 5. We go up 5 when we get to 1. And then we go up 1, 2, 3, 4, 5 more when we get to 2. So this is the line that we're looking at. We care about it between 0 and 2. So basically, we're looking for what's this shaded area here. In order to find that shaded area, we're going to make an approximation. The approximation is going to be based off a set number of rectangles, in this case 4 rectangles. So if I look at these 4 rectangles as left-sided rectangles, I need to figure out what are the 4 places that I need to find f values for. So I'm going to take b minus a, in other words, the end of the interval minus the start of the interval, divided by rectangles. In this case, 2 minus 0 divided by 4 tells me that the base of each rectangle would be 2 over 4, or 0.5. So from my starting point, I have to move 0.5 each time. So here's where I started at 0, here's 0.5, here's 1, here's 1.5, and here's 2. If I'm looking for left-sided rectangles, basically they're going to start wherever the y value is on the left side and go up to where my rectangle ends. And then I'm going to do the same thing here at 0.5, the curve's about there. So this would be my left-sided rectangle. Here at 1, the curve's here. So this would be my left-sided rectangle. And finally at 1.5, so the curve's here. So this would be my left-sided rectangle. If I look at these left-sided rectangles, this would be the area they take up, which would leave this, and this as blank areas that really aren't being added when I find the area. For that reason, the left side here is going to be an underestimate of the true area. If instead I looked at it as being right-sided rectangles, I have the same general setup. The difference would be here at 0.5, I would start with the right side and draw my rectangle like this. Here at 1, I'd start with the right side, draw my rectangle like this. At 1.5, and then finally at 2. In this case, it would tell me this whole shaded area is the area under the curve given right-sided rectangles. The same way we had an issue with left-sided, that this empty space wasn't being counted. When we do right-sided, we're counting this extra space on top of the curve that really shouldn't be counted. So neither of them is perfect. Basically, looking at area this way is going to build us towards integration, which is absolutely perfect and gives us exactly what we want under the curve. But the goal for now is to say, how could we do it if we see it in this rectangle method? So what I'm going to need to find is f of 0, f of 0.5, f of 1, and f of 1.5. I can do it graphically, or it's probably easier if I just plug into the formula. If I put 0 into 5x plus 2, 5 times 0 plus 2 gives me 2. If I put 0.5 in, 5 times 0.5 plus 2 gives me 4.5. If I put 1 in, 5 times 1 plus 2 gives me 7. And finally, if I put 1.5 in, 5 times 1.5 plus 2 gives me 9.5. So basically what these have done, they've given me the height of each of these left-sided rectangles. If I now want to find the total area occupied by these rectangles, I'm going to use my formula for a rectangle's area, which is base times height. These represent the heights of rectangles. If we multiply them, times the base, which each time was 0.5 that I moved. That would tell me the area of each of these left-sided rectangles. So 2 times 0.5 gives me 1. 4.5 times 0.5 gives me 2.25. 7 times 0.5 gives me 3.5. And 9.5 times 0.5 gives me 4.75. These are the individual 4 left-sided rectangle areas. If I summate them or add them all together, that'll give me the total area of these 4 rectangles. So 2.25 plus 4.75 gives me 7, plus 1 gives me 8, plus 3.5 gives me 11.5. This is the correct answer for the area under the curve using left-sided endpoints. If I now go down to my second drawing and I want to start doing right-sided endpoints, this first rectangle ends at 0.5, so it would be f of 0.5. Second one would be f of 1, third would be f of 1.5, and finally I'd get to f of 2. Notice that we've already done these 3. So really, when I change from left to right side, the only real change is I no longer look at the left side of the first one, and I now look at the right side of the last one. But really, these 3 rectangles are the exact same as these 3 rectangles. So it's just a question of take away that first rectangle from left-sided, add in this last rectangle from right-sided. So we know these 3 already from above are going to be 2.25, 3.5, and 4.75. If we go to find f of 2, 5 times 2 plus 2 gives me 12. If I multiply that by 0.5, I get 6. So for my right side, I want to add together these 4 rectangles. Really, what I'm doing is I'm taking away this 1 and I'm adding in this 6. So I should end up getting 5 more than I got before. That said, let's actually do it out to make sure that's the case. These 2 add to 7 plus 3.5 gives me 10.5 plus 6 gives me 16.5.